Hello students, today we are going to discuss about humidification equipment, various type of equipments available in industries for humidification operation, and they are discussed below. Types of humidification equipment, first one cooling tower, second one spray chamber, third one cooling fan. One by one we will discuss. First one cooling tower. Cooling tower classified into three types. First one natural draft cooling tower, second one mechanical cooling tower or forced draft cooling tower, third one induced draft cooling tower. So induced draft cooling tower classified into two types. One is cross flow induced draft cooling tower, another one counter flow induced draft cooling tower. One by one we will discuss. First type, natural draft cooling tower. This is also called hyperbolic cooling tower. Meaning of hyperbolic, enlarged structure. So here the pond is located at the bottom of the tower. Air is entering the both side of the tower. Hot water from condenser enter into the tower through water spray. Purpose of this water spray, the uniform liquid distribution. So here the hurdles are attached in the tower below the water spray. Purpose of this hurdle to reduce the speed. So here the eliminators also attached in this tower above the water spray. Purpose of this eliminator to remove the dust particle, particularly very fine particle. So here outer cover of this tower is reinforced concrete cell. This entire process releases the hot air at the top of the tower and also cold water sent to condenser through pump at the bottom of the tower. So here natural draft cooling tower operate on the stack effect. Stack means that is a physical structure which causes the hot air in the tower to rise. Wet natural draft cooling tower used mainly for electrical energy industry but can be used for other industrial objects. Such tower allow the cooling of high water volume and are designed both from concrete and metal structure. Advantages and limitations of natural draft cooling tower. Advantages: power saving, no power consumption to induce airflow. Why? Because no external devices like fan or blower. This is natural draft cooling tower. Environmentally friendly. This is a easier operation. No mechanical noise. So why? Because this is the natural draft cooling tower. No external devices used here like fan or blower. Safety of operation. This is easier operation. Limited maintenance. No mechanical devices used here. Payback period between 8 and 16 years depending on several factors. So like pressure or temperature or airflow rate, etc. Limitations of natural draft cooling tower. A higher investment cost. Large overall dimension that could cause difficulties with the area aesthetics, that is beauty, and requirement of large area for tower installation. Second type, mechanical draft cooling tower. Mechanical draft cooling tower are very much similar to that of the natural draft cooling tower. The name indicates air is circulated inside the tower mechanically instead of natural circulation. Propeller fan or centrifugal fan may be used. So here propeller fan or centrifugal fans also called external devices. This figure shows that mechanical draft cooling tower. So here air is entering at the bottom of the tower through external devices like fan or blower. Here propeller fan or centrifugal fan may be used. Are you clear? Okay. So from heat exchanger water is entering at the top of the tower through water spray. Purpose of this water spray, uniform liquid distribution. So drift eliminators also attached in this tower above the water spray. Purpose of this drift eliminator remove the dust particles, particularly very fine particles. Are you clear or not? Okay. So this entire process releases the hot air at the top of the tower, and also cooled water sent to heat exchanger. So in this tower, fills also used. What is the purpose of the fill here? Fill is the medium used in cooling tower to increase the surface area of the tower. Increased surface area allow for maximum contact between air and the water, so which allows for greater evaporation rate. This is the purpose of the fill. Advantages and limitations of mechanical draft cooling tower. Advantages: same capacity use, mechanical draft cooling tower size is smaller than the natural draft cooling tower. So why? Because increase in cooling capacity due to increase in volume of the air being forced out by fan. So that's why the mechanical draft cooling tower also called forced draft cooling tower. Capacity control is possible in mechanical draft cooling tower by controlling the speed of the external devices. Volume of the air can be controlled, which in turn control the capacity. So this tower do not depend upon the atmospheric air. The mechanical draft cooling tower shall be located even inside the building. So why this tower do not depend upon the atmospheric air? So this is called forced draft cooling tower. Mechanical devices also used here. So that's why do not depend upon the atmospheric air. Are you clear? Okay. So the limitations of mechanical draft cooling tower, more power is required to run the system. So because more mechanical devices also used here, like fan or blower or any other devices like fill, then motors. So due to this, more power is required to run the system. So the running cost also increase because of increase in maintenance of the external devices like fan or motor and its associated control. Are you clear? Okay. Next one, induced draft counterflow cooling tower. This is also called mechanical draft cooling tower. Why? Because mechanical devices or external devices used in this tower. What are the external devices? Fan or blower. So in this tower also called counterflow cooling tower. Why? Because the flow directions are opposite direction. Are you clear or not? Okay. So the figure shows that induced draft counterflow cooling tower. In this tower, air is entering both sides of the tower at bottom. Hot water from condenser is entering at the top of the tower through water spray. Purpose of this water spray: uniform liquid distribution. So here spray eliminators also located at the top of the tower or above the water spray. Purpose of this spray eliminator: prevent the water droplet and mist from escaping the cooling tower. Next one is the packing. These packing located below the water spray or water distribution layer and above the sump of the cooling tower. So it is also referred to as heat transfer pack. Purpose of this packing in this cooling tower: it provide large surface area for evaporative cooling to take place. Are you clear? Okay. So the entire process releases the hot air at the top of the tower. So here the cooled water also sent into condenser at the bottom of the tower. Are you clear? Okay. So here in this tower with a fan at the discharge which pulls air up through the tower. So the fan induces hot moist air out the discharge. So here this tower produces low entering and a high exit air velocity. So because of this, reducing the possibility of recirculation, in which discharge airflow back into the air intake. Are you clear or not? Okay. Next one is the induced draft cross flow cooling tower. It is also called mechanical draft cooling tower. Why? Because mechanical devices or external devices used in this tower. What are the external devices? Fan or blower. Are you clear or not? Okay. So in this tower, the fan also used as a external device. Are you clear? Okay. Yes. So this figure shows that induced draft cross flow cooling tower. Why it is called cross flow cooling tower? Water vertically flow through the film media while the air horizontally flow across the falling water. So that's why this is called cross flow cooling tower, because of the air and water cross path are close. See the figure. The air and flow liquid directions are cross flow direction. Because of the crossing of flow, air does not need to pass through the distribution system. This permits the use of hot water flow via gravity and distribution basin on the top of the tower right above the film media. Which one is the distribution basin here? Water spray. Purpose of this water spray, uniform liquid distribution. Are you clear or not? Okay. So next one is the spray eliminator. Purpose of this spray eliminator in this tower, prevent the water droplet and mist from escaping the cooling tower. So here spray eliminators also located below the water spray. Here the one more additional information here, packing. Purpose of this packing, it is also to act a heat transfer pack. It provides large surface area for evaporative cooling to take place. Are you clear or not? Okay. So here this entire process releases the hot air at the top of the tower. So and also cooled water sent to condenser at the bottom of the tower. Distinguish between natural draft cooling tower and forced draft cooling tower. Size and shape. In natural draft cooling tower, height is 125 meter, diameter is 100 meter. It is a hyperbolic shape. Hyperbolic is a enlarged shape. Whereas forced draft cooling tower, height is 15 meter, length is thousands of meters. It has a long rectangle box shape. Initial cost, in natural draft cooling tower, high cost compared with forced draft cooling tower, whereas forced draft cooling tower 50% of natural draft cooling tower. Operating cost, forced draft cooling tower operating cost is high compared with natural draft cooling tower. So the maintenance cost also high in forced draft cooling tower compared with natural draft cooling tower. What about the water loss? Water loss is more in forced draft cooling tower compared with natural draft cooling tower. Life or depreciation, in natural draft cooling tower life is more compared with forced draft cooling tower. Thank you for your attention.